Here we have two functions, f of x equal to 2x plus 2, and g of x is equal to x squared plus 2x plus 1. First part, we want to find f plus g of x. This means just taking the f of x and add it to the g of x. F of x is 2x plus 2. Adding that to the second function, g of x, which is x squared minus 2x plus 1. Just combine like terms. We have x to the power of 2, one of them here. We have 2x minus 2x, that adds up to 0. And then we have plus 2 and plus 1, that adds up to plus 3. So this would be f plus g of x. The second one, we have f g of 2. So it means we need to find f g of x first. We can do that, which is the same as f of x times g of x. F of x is given to me as 2x plus 2. And g of x is given to me as x squared minus 2x plus 1. We can distribute here. We would get 2x to the power of 3 minus 4x to the power of 2 plus 2x. Then we continue with distributing. Then we get plus 2x to the power of 2, and then we get minus 4x plus 2. We can combine like terms. We have 2x to the power of 3. Here we have 4 minus 4x to the power of 2 plus 2x to the power of 2. That adds up to minus 2x to the power of 2. If I combine 2x and minus 4x, that gives me minus 2x. And then we have only one constant here, plus 2. So this is f times g of x. But we want to know what f times g of 2 is. So if I substitute for each x2 here, then I can find this. Right, then you just simply plug, like you said, for each x, you substitute for each x this value here. In this case, is 2. And then you evaluate that. So I give you 8, give me 4, give me minus 4 plus 2. So you get 16 minus 8 minus 4 plus 2. So can anybody tell me what this is equal to? So what is 16 minus 8? 8 minus 4 plus 2. 8 minus 4 would be 4 plus 2. So the whole thing is equal to what? 6. So you see we get the single number here that is equal to 6. Okay. Given a graph, what type of test we use to find whether that represents a function or not? Anybody remember the test? What's the name of the test? Vertical test. Very good. Somebody says vertical test. Vertical test. Okay, let's see what that vertical test does here. So if I come up with the graph, let's look at a couple of graphs here. So if I have 3 graphs here. Okay, first one I'm gonna make it look like a parabola going up, and the other one I'm gonna make it go like that, and the other one I can make like a circle like that. Okay, so we want to use a vertical test to see whether this is a function or not. So we need to draw a vertical line like this. And if I move this vertical line to the right and left through the graph, if this vertical line intercepts your graph exactly at one point and one point only, then that would represent a function. So we can say this is a function. That's a vertical test. Function. How about the second one? Is that the second one a function? If I take my vertical test here, but that doesn't look like a function, is it? Because the vertical test violates the definition of vertical. So if these 2 lines would be right on top of each other. So let's come up with some number here. If this is 2 here, and if this is, let's say, -1 here, and this is 3 here, we're just making numbers. So these points here looks like they're sharing the same x-axis, 2 and 3, and this point here would be 2 and -1. So if you look at the set of numbers that represent any graph, if you detect a point that shares the same x-axis, what that means is you have 2 points right on top of each other. In other words, you're going to violate that vertical test. So sometimes you don't have a graph, that's all you have is just a bunch of order pairs, and they ask you whether this is a function or not. So that's all you look for, is you want to make sure that neither of these order pairs share the same x-axis. If they do, it means you're looking at 2 points right on top of each other, means they're violating the vertical test. So then you say it's not a function. So this is not a function. Not function. How about the third example, third graph? Is that a function? No, if I draw a vertical test here, and I move this vertical test around, it's going to intercept my graph more than one point all over, right? So the circle is not a function. That doesn't represent a function. How about the straight line? Can I say all straight lines are functions? So if I graph a line here, let's say this is my y-axis, this is my x-axis, and if I have a line like this, let's have a straight line. Okay, is this represent a function? Is this a function? Yeah, because if I draw a vertical line through that, it's going to intercept my line only at one point. So can I say all linear equation, all vertical lines are all lines, all straight lines are function, except what line? except it's a vertical line, right? As long as it's not a vertical line, all other lines, all linear equations are functions then, right? As long as they're not a vertical line, that would be represent the function. So this would be a function. So they're asking me what kind of test you're going to use. That's called vertical test, to see whether it's a function or not. If you do have a graph in front of you, you can use the vertical test to see whether it's a function or not. If you have order pairs only, then you're going to make sure that none of these order pairs share the same x-axis. What happens if they share the same y-axis? What would that happen? If you have if they share the y-axis, means the points would be right next to each other, right? Then it would violate a horizontal test. Anybody know when we use the horizontal test? When do we check whether a function for the horizontal test? Okay, for horizontal test, we're going to get to this concept a little bit later. If the function is one-to-one, if you already established that we have a function, and then we want to know whether it's a one-to-one function, then we use the horizontal test. So if we do pass the horizontal test for any function, then we can establish that is a one-to-one function. So this linear equation here, this example here, not only is a function, also is a one-to-one function, because it's also going to pass the horizontal test. If I draw a horizontal line, it's going to intercept that at one point and one point only. So if I look at the first example here, this is a function. We established that the parabola opens upward it's a function. However, it's not a one-to-one function because it's going to violate the horizontal test. It's not a one-to-one function because if I look at this two-order pair, then I would see if this is 2 and this is -2 and this is, let's say, 2, doesn't matter. Just making up numbers here. You got 2 and 2, and this is -2 and 2. So now you see if fails the horizontal test, then we have numbers the same in our order pairs on the y-axis. Okay. So this one here is a function, but it's not a one-to-one function because failed the horizontal test. We use the vertical test to see whether it's a function or not. Okay. If I have absolute value of x is greater than a number or less than a number, if you look at the solution set here, the first one, absolute value of x is greater than 2. So if you pick 2 here, number 2, and -2 here, that means all the numbers that are larger than 2 units away from 0. What are the numbers that are larger than 2 units away from 0? Would be all the numbers to the right of 2 and all the numbers to the left of 2. These are the ones, right? So that corresponds to all the numbers that are larger than 2 or all the numbers that are less than -2. But if I have absolute value of x is less than 2, means all the numbers that are less than 2 units away from 0. So that corresponds to these areas here. So all the numbers in between 2 and -2. Again, interval notation, we talked about interval notation. Please make sure that you know how to do that because we're going to see this on the exam. So if I want to write this in interval notation, I'm going to use parentheses, 2, comma, infinity, or here would be parentheses, -2, comma, minus infinity. If you want to include the endpoints if 2 and minus 2 are included, or for instance equal to here, then you have to use brackets for the endpoints instead. So if I had equal sign here, so I'm going to include the endpoints also. So if I want to write the interval notation, I've used the brackets instead of parentheses, because minus 2 also at the end is included. Okay. And if I have absolute value of x is equal to 2, that means all the numbers that are exactly 2 units away from 0, and we would have only 2 numbers that are exactly 2 units away from 0. It would be x would be equal to 2, and another solution would be x is equal to minus 2. So if instead of x I have expression, any expression, you just take those expression and plug it into these regions to find the solutions for x.